Let us take question number 61. The species which is seesaw in shape is, we have different options: silicon chloride, PCl4 positive, SF4, ammonium ion, NH4 positive. In this case, if I talk about this SF4, its hybridization is sp3d, just recall. And the shape of this SF4 is seesaw. There's a lone pair on the sulfur atom in this way, and 4 fluorine atoms are attached in this manner. So this is seesaw shape, and that's why this SF4 becomes the correct answer for question number 61. After that, question number 62. Most unstable metacarbonyl among the following is, we know that all those carbonyls which are following EAN rule, effective atomic number rule, those are considered as stable, and if they are not following that, they would be considered as unstable. So if I talk about nickel carbonyl, we need to just check its EAN value. What would be that? For nickel carbonyl, it would be, I'm just writing here, EAN value, effective atomic number, that is equal to 28. No charge on this complex. Oxidation number of nickel is 0. Then number of ligand 4 and 2 electron from each of these ligand, 2 into 4. So this value is equal to 28 plus 8, 36 electron. And if effective atomic number is 36, it means this is the atomic number of nearest noble gas, krypton. That's why it is stable. That's why I'm writing here S. Further, we have the second option, vanadium carbonyl. Now, I'm just going to calculate its EAN value. That is equal to 23, the atomic number of vanadium. Then there is no charge on the carbonyl. That's why oxidation number of vanadium is 0. Then 6 into 2. That would be equal to 12 plus 23, 35. It means it is unstable because its effective atomic number is not equal to the nearest noble gas. That's why it becomes unstable. Further, let's check the further option also. Though we know that the correct answer is option 2, but still. FeCO5, for this the effective atomic number would be 26 plus 5 into 2. That's 36 once again. It is stable. Further, chromium carbonyl we have. Atomic number of chromium 24. No charge on this carbonyl. Oxidation number of chromium is 0 in this case. Plus 6 into 2, 12. So this is also 36. This is also stable. Only one is unstable. That is given here in option 2. So the answer becomes option 2. After that, 63. If the equilibrium constant for a reaction is 2 into 10 raised to the power 3 at 25 degrees Celsius, then the standard Gibbs free energy change for the reaction is, we know that delta G is equals to minus 2.303 RT log Kc. This is the expression for the Gibbs free energy change and the equilibrium constant. In this case, this would be minus 2.303 R. What is T value? That is 25 degrees Celsius, becomes 298 Kelvin, and log Kc. What's the value of Kc? That value is clearly given here, 2 into 10 raised to the power 3. So I'm just placing value here, 2 into 10 raised to the power 3. So it can be represented as minus 2.303 into R into 298, and it can be written as 3 plus the value of log 2, that is 0.3010. So that I'm writing here 3010. That would be equal to, this becomes 3.3010. Now this expression can be matched here. This is minus 2.303 into 3.3010 into R into 298. And if you multiply these two, 2.303 and 3.3010, 3010. This is equal to approximately 7.6, and this is R into 298. It means this is your final answer. And this answer is correctly given here in option 2. So just choose option 2 as your correct answer. After this, question number 64 we have. Consider the following equilibrium reaction. 2NO is reacting with O2, gaseous mixture it is. Further, 2NO2 is formed, nitrogen dioxide is formed. If helium gas at constant pressure is added to the above equilibrium, then we should know that addition of an ideal gas at constant volume does not affect equilibrium. But if you are adding some ideal gas at constant pressure, in that case, volume is increased. And as the volume is increased, it means number of gaseous moles present per unit volume are decreased. So definitely equilibrium will shift in that direction where the number of moles are increased. So we need to just check in this case where the number of moles are increased. In this case, the number of moles are increased in the backward direction. It means where this NO2 or the nitrogen dioxide is dissociating. So simply we can say in this case dissociation of NO2 will increase because equilibrium will be shifted in that direction. And on that basis, option 2 becomes your correct answer. After that, question number 65. 100 ml of 0.2 molar acetic acid is titrated with 0.2 molar NaOH solution. The pH of the solution at equivalence point will be, pKa value is given, that is for acetic acid, it is 4.76. So actually in this reaction, acetic acid is reacting with a strong base, a weak acid is reacting with a strong base, and there's the formation of a salt, that is CH3COONA, sodium acetate, and water is formed. In this case, you have 100 ml of 0.2 molar acetic acid and 0.2 molar NaOH is taken in the burette, that is in excess, and here is the formation of sodium acetate. So first we'll find out the millimoles of sodium acetate. Millimoles you can easily calculate because we know the volume. On the basis of stoichiometry, we can check here millimoles, that would be 100 into 0.2 for the sodium acetate. So these would becomes 20 millimoles. Now, total volume at equilibrium, as the equilibrium is set here, at this case, what would be the total volume? 100 plus 100, it means 200 ml. Because acetic acid you are taking with NaOH, and ultimately the total volume becomes 200 ml at equivalence point. Now, in this case, what would be the molarity of the salt? We know that molarity is equals to the moles divided by the volume, and that should be in liter. But here we are talking about the millimoles, that's why I'll take the volume in milliliter. So molarity is equal to 20 divided by 200. Millimoles are divided by volume in milliliter. So it would be equal to 1 by 10 or simply 0.1 molar. This is the molarity. Now what we need to find out? We need to find out the pH. For the salt of strong base and weak acid, the pH value is equals to 7 plus half pKa plus log C. This is the formula for the pH calculation. Let's place the values here. It would be 7 plus half. What is pKa value? Correctly given here in the question. That is 4.76 plus log C. C is 0.1 that you have just calculated. This would be the value. Now, if you solve this for the value of pH, it would be equal to 8.9. You will obtain it after calculation, and this is correctly given here in option 2. So just choose option 2 as your correct option.